the keyword override. Okay. So let me summarize whatever we learned so far. Okay. We learned some of the rules of the inheritance. Okay. So we came up with 6 rules. Okay. We learned some of the keywords that we use in C# to eliminate ambiguity as related to inheritance. Okay. So let's summarize those. Okay, so for inheritance, the idea was start creating some classes. As soon as you've written a few classes, you yourself will discover that you are repeating things. Okay, so as we saw through the color coding, if this part, this part, this part, this part, this part, this part is the same. Okay. At that point in time, you will create the base class. So let me emphasize, good programmers do not start with the base class first. Okay, good programmers will create the real physical entity classes first, and then they will discover we are repeating things, and then they'll take the common things out. And the reason is because we inherit everything. Okay. If we created the base class first, we may end up putting something over here which is really not needed in a derived class, which is violation of one of the important rules in good software development, right? So anyway, as we create the base class and move the common things over here, so these go away, right? Okay, now we can of course add more fields. So you can add an extra field over here. You can add 2 extra fields over here. It doesn't matter. You can add extra method over here, add extra method over here, right? But what if we wanted to override it and provide our own code, not the code that was written in the base class? Okay, then how will we mark this method over here, which already has real code in it? Virtual. Okay, so we'll mark it as virtual. And then we will override it, right? Now what if we, from here, we further create another class, and we further wanted to override it? So from an override, you can keep going and keep overriding as many times you feel like it, right? Now suppose there was another method over here, okay, which has identical signature. Okay, but code is different. Then how will you declare it? So you will not put any code over here, you will put abstract over here. Correct? Mm-hmm. And then as you inherit from here, because you're writing some real code over here, so you will use the keyword override over here and override over here. Okay, so let me go to my computer, and I'll show you very quickly some of the code that we will need to create the university application, and how gradually we'll refactor it. Okay, or let me briefly describe it first.
I have a question. So you talked about how you can, the 3 ways to signal that you can override a method is through abstract, virtual, or override.
Correct.
If you're using override to override another method, is it possible to start the chain of override? For example, in the base class, they use override instead of virtual. Would that functionality?
No, in the very, very top level class, the chain is started with the virtual keyword. And why virtual? As I explained, I'll go over it a little more detail, maybe in the next lecture, so that you completely understand. Okay, so now let's pretend our goal is to create a university application. Okay, and let's pretend the real entities that we will create, meaning the classes and the objects that we will need to create in our application. And again, let's pretend we have a part-time student. We have undergraduate student. We have a grad student. We have a PhD student. Okay, so this is the student side, right? In a university, we also have employees. Okay, we have professors. So pretend there's a faculty. There's an employee. Okay. There might be. So anyway, there might be, dorms and so on, and labs and so on, and lab managers and so on, right? But to keep the example simple, right? Let's start over here, okay? So as I mentioned, if these are the real entities that you wanted to create in your application, you'll start creating classes for these, right? So you'll create a class for part-time student, undergraduate student, grad student. Okay, for right now, let me assume this uses 0.4 times the formula for computing grade, 0.4 times, 0.4 times, let's say 0.5 times for a PhD student, okay? So let's start from the student side, right? So you may start creating a class called undergraduate student. Okay, you'll put the 5 fields over here: first name, last name, ID, test 1 and test 2, right? Okay, and you will also write the formula for compute grade. And with the 0.4 times whatever code, right? Okay, then you'll start with the grad student. Okay, and let's pretend that these 5 fields are the same, but the extra field is the thesis. And you will write the code for the compute grade. And 0.4 times, so same formula. So as soon as you have created these 2 classes, what will you do? You will create base class. Okay. What will you call the base class? Okay, you can, again, in the beginning, even if you didn't pick a perfect name, it's okay. Gradually, you will recognize we need to change things. You will, what's called refactor your code. Okay, so let's go create a base class called student for right now, okay? What are the common things over here? The first 5 fields, right? So let me mark those. Those were the common. So I'll put them in the same color, but thesis is not common. So 5 fields, okay? Is the compute grade the same?
Yes.
So you will also put the compute grade over here, okay? With 0.4 times whatever code, right? Now, tomorrow, somebody may want to override it and provide a different code. So to allow somebody in the future to be able to inherit from student and change the code for compute grade, what will you mark it as? Virtual. So let's mark this as virtual. Okay. So now over here you will go and inherit from student. So what happens to all the code over here? Disappears. See how easy it is to create the class now? Okay. What happens to the code over here? Only thing remaining is pieces, right? Now let me mention also, we had gone over this before, we always write two constructors, okay? One with as many parameters as the number of fields, and one with no parameters. Because as soon as we write a constructor with parameters, C# takes away the default constructor, right? Okay, so I forgot to give you one rule special to C# related to inheritance, and one extra rule is constructors are not inherited in C#. Unlike C++, where the constructors are also inherited. Okay. So if we write a constructor in the base class, it will not be available in the derived class. Okay. So over here, how many constructors you will write? Right? Constructor without any parameter. And constructor with five parameters. Everybody agrees? Remember, the constructor has the same name as the class name, no return type. So for example, how will the first constructor look like? Public student, begin curly, end curly, no code, right? How will the second constructor look like? Public, same name as the class name. Now 5 parameters. For example, string LNM. Sorry, let's start with the first name. FNM, LNM, and int ID, int test1, int test2, right? And then what kind of code over we'll write? We will say first name equal to FNM, last name equal to LNM, this dot ID equal to ID. So again, to eliminate any confusion, when we use the this keyword, we are talking about the field of the class, okay? And this ID is the parameter ID over here, okay? And very similarly, this dot test1 equal to test1, and this dot test2 equal to test2, right? Everybody okay? So now let's go to the student class. How would we write the constructor over here, okay? When we use inheritance, right? So first constructor is easy. We will say public UG student, begin curly, end curly, no code, okay? What about the second constructor? Public UG student, and again, string first name, string LNM, so all the 5 parameters, right? Now, the base class constructor is already doing the initialization of the 5 fields. So in C#, very similar to C++, there is a concept called the initializer list. So in the same row where you're declaring the constructor, you will simply say base, FNM, LNM, ID, test1, test2. Okay, and so we are delegating the work of the initialization to the base class and no code. So this is how when inheritance is involved, we delegate the work. So base is the keyword used in C# to delegate the work to the base class. Okay, very similar to like in Java, we use the keyword super. Okay, so it's the same thing. Okay, anyway, so that's how you will write the constructors. Okay, so now let's come to the class. What was it? We said grad student will also inherit from student. Okay, you will write the constructor. Okay, first constructor will be parameterless constructor. What about the second constructor in the grad student? How many fields will it have? Six, right? Because remember we added the thesis field over here. Okay, so again what you will do is you will delegate the work of initialization of the first 5 fields to the base class. Okay, so the constructor that we write over here in the grad student will look exactly like this with one small difference. For the grad student, there will be one extra parameter over here called thesis, correct? For the grad student, there will be one extra parameter over here, string thesis, not over here. Because the base class constructor only takes 5 fields. So the work of initialization of the first 5 fields will be delegated to the base class. Okay, what about the 6th field now? We have to do it manually. So you will have to say this dot thesis equal to thesis. So this line will be added for grad student class. Make sense? Okay. So I'll be giving you an assignment this week, which will be due next week, where you will create this university application. Okay. So whenever you're writing every class, you will be giving me 2 constructors. Okay. And once inheritance is involved, you will delegate the work as much to the base class as possible. Okay. Anyway, coming to now the compute grade over here. Do we have to write the code for compute grade over here? If it is using the same 0.4 formula?
No.
Do we have to write the code for the grad student compute grade? No. Let's go to the PhD student. So now if we create a PhD student, so class PhD student, okay, let's pretend it will have one extra field over here. Instead of thesis, the field will be, let's say, dissertation. Okay, so there will be a field over here, dissertation, instead of thesis. And you will also have a PhD advisor and one more extra field over here in the PhD student class. Okay, so where will we inherit it from? Student. Can we add these 2 fields over here?
Yes.
So yeah, we can add string PhD advisor and string dissertation as an example, right? Okay, you'll provide the constructor over here, default constructor, no parameters, easy. What about the second constructor? How many parameters? 7. The work of initialization of the first 5 will be delegated to our base class constructor, right? Okay. Now let's go, what about the compute grade method over here? How will you declare it? We have to override. And what does that mean? That in the student, it has to be declared virtual, right? Okay. Okay, so anyway, now let's go to part-time student. And of course, you can put the code 0.5 times, so on. Okay. now let's pretend the part-time student has no ID. Okay, it does have first name, last name. Let's say a part-time student goes by the social security number. Okay, and of course we'll take test 1, test 2, and let's pretend the formula will be 0.35 for the part-time student. So this is for part-time. So no ID, instead we have social security number. So now let's come over here. So what should we do now?
Declare social security.
Can we inherit it from the student? See, if we inherit from student, what's the problem? We'll end up getting ID over here, right? But there is no ID for a part-time student. So remember, that's a violation of the proper object-oriented programming, right? So that means we need to change our hierarchy. We need to create a different base class, okay? So what's common between, let's figure out, what's common between all 4 types of students? Right? So now at this point in time, you will come over here, you'll refactor the student, meaning change the code, and what will you do? Eliminate the ID. So what does that mean over here? You will add ID. You will add ID over here, right? Okay, the other problem is, if we go over here, where we were writing the code 0.4 times, okay, part-time student uses 0.35 times. We could override it, or let's mark it with abstract. So let's mark the compute grade over here as abstract.
So there is no
Okay.
code here.
Okay, so now the problem is, if we override over here, so because it's abstract,
But that's
that means we will need to write compute grade over here, correct? And provide the real code with the 0.4 formula. Will we need to go over here, override the compute grade, and provide the 0.4 formula code, right? So aren't we repeating code? See, in good object-oriented programming, as soon as you see yourself repeating code, that means you need to refactor again, okay? So my suggestion will be, do this. Create a class called student, which will act as the base of all students. Then from here, let's derive another class called full-time student. Okay, what fields will we have over here? First name, last name, ID or no ID? No ID, okay? And test 1, test 2, and the abstract compute grade. Everybody agrees? Okay, now let's go to full-time student. What will we be adding over here? And by the way, because it's abstract, how will you mark the whole class? Abstract. Now let's go to the full-time student. Okay, what field will you be adding over here? ID. Now from this one, you will inherit, okay, and will you provide the code for compute grade over here?
Yes.
So there will be real code or abstract?
Real
Real code. And this will be marked, no, override.
Override.
Because it was abstract, from here we overrode and provide the real code, right? Now from here, what classes will we inherit? UG student, because it uses the same 0.4 formula, and the grad student. What about the PhD student? PhD student, we can So this will have no code for compute grade, correct? And what about this?
No code.
No code. What about PhD student? Override code for compute grade. And then you will provide the 0.5 formula, correct? For a PhD student, we wanted 0.5, okay? Now, let's go to the part-time student. Where will the part-time student inherit from? So part-time student will not inherit from a full-time student. So from here, we will inherit part-time student. What fields will we add over here? Social security number. And what else will we do? Override compute grade with the 0.35 formula, right? So we said this is 0.35 formula for part-time student, right? Okay. So our hierarchy, as you can see, will look something like now. Student. From student, we go to full-time student. Is this abstract?
Yes.
What about this one? Is this abstract?
No.
No.
Okay, see, even though there's no abstract method over here, okay, you should still mark it as abstract. Reason is because the real entities that exist in the real world, there's no such thing as a full-time student. See, even if you see some student, you ask them, they'll say, I'm an undergraduate student or I'm a grad student. They will, so because it's just our own classification, okay, you will mark it as abstract to prevent anybody from creating an object of full-time student.
Professor,
Okay.
but in the full-time student, we are writing the function
Yeah.
with a real code.
You can still have real code in it in an abstract class. Okay. The only thing is you cannot create an object of it. Okay. So from here, as we discussed, we will create undergraduate, grad student, and PhD student, right? And from here, we will create part-time student. Okay, what time it is? Do I have a few more minutes? No? All right. Okay, so I'll create an assignment, put it on the website. Okay, so this will be due next week. So you have to write the real code using Visual Studio for all these classes. As you are writing the code for faculty, anyway, I'll explain what fields they have, and you will submit it next week. And how to submit it, I'll put it on the website. So this will be due Wednesday.